To take a car and have this sandpaper represent some real good tires on the car. And we have the three different road surfaces here. This represents an asphalt surface that has gravel embedded in it. This represents a worn concrete roadway that's been polished over many years of use. And this represents some black ice. And if we take the car with good tires and the best roadway, and we place the car onto that road, plastic, and attach it to the outside mirror here, and stretch it out until it loses traction, which is at about 13 to 14. We could do it again, see the consistency that we're going to get, so that this car's limitation would be at 13 units of grip that we're just using as a representation of how much coefficient of friction we have. Now when we go on this roadway, which is concrete, then we start losing it at about 9. And when we place it onto the ice, there's only 2 units of grip here before we start to lose it. And of course, the more energy we put into the situation, like let's suppose that we're on a perfectly dry road, good tires, excellent traction for the road surface, but we go in with excessive speed, which we will represent by putting in this amount of energy, and you see how fast the car breaks away. So when the car breaks away so quickly, the driver doesn't really have a chance to get the car back in control. But when the car just starts to move off target, as it is here, it just moves very gradually off target, we could put in a small correction and be able to get the car back in control. When it happens so quickly, we lose the opportunity to get the car in control. Well, what are some other factors that affects the traction that we would have? Suppose that we had bald tires, worn tires, instead of tires with real good grip to it. So we'll just reverse our sandpaper here and use the bald side on a good roadway. And now this roadway where we had 13 to 14 units of grip, we're only getting 8 units of grip. Why? Because our tires are worn and they're not sticking to the roadway the way that they should. Then it would reduce our traction for all of the surfaces. Or suppose we had some real good tires and we're on a real good roadway, asphalt, but it's raining, so we'll put this piece of plastic here to represent the separation between our tires and the road, and there's how much traction we would have. We have an excessive amount of water, we have a rain situation, then the car is going to act just like it's on black ice. Or a problem that we sometimes have is we drive on a road surface that has gravel on it. So we'll just put some sand here to represent loose gravel on a road. So we go off of one roadway, we make a turn, and all of a sudden we're on this type of a road that has some loose gravel on it. We have the good tires, a good road, we have good tires, and we have a road with gravel on it, and we start to lose traction at 8 units. Take away take away the gravel, put our car onto a road that has a solid surface to it, and we get up to 13, 14 units of grip. We're always changing, and this is not necessarily winter driving conditions. This happens all year long. This could happen in Texas, it could happen in Montana, it could happen in any state that, in any road that we operate on. We never operate on the same road surface. We never operate with the same car conditions, and we lose pressure to our tires. It's going to change the weight distribution of the car. That's going to affect how we operate. So the only thing that we could rely upon is the habits that we have. And if we have the proper habit for reducing our speed before we go into a curve, then it doesn't matter if all of these other factors are working against us. We have this working for us, the correct habits. And that's what training is all about. How do we acquire the habits that are going to give us protection?